Hello. What I'd like to do here is find the absolute value of a complex number. It sounds kind of daunting or scary, but it's really not. I don't really need to graph it, but I'm going to graph number 1, 3 plus 4i, that complex number, to give you my interpretation of what it means to find the absolute value of a complex number. So, in order to graph 3 plus 4i, I have a real axis and an imaginary axis. And the 3, well, that's a real number. And the 4i, that's kind of imaginary because it has an I after it. So all this means is I go right 3, 1, 2, 3, and up 1, 2, 3, 4 on the imaginary axis. And all they're looking for is how far that point is from 0. Well, this can be thought of geometrically as a Pythagorean Theorem problem, because I have this distance now as 3, and I have this distance as 4. So in order to find the hypotenuse, all I need to do is implement the Pythagorean Theorem, which is a squared plus b squared equals c squared. So when I do Pythagorean Theorem for these, I just set up my c squared. The inverse of c squared is the square root. So a squared and b squared. And all I do is plug in those values. So the 3 goes here, and the 4 goes there, and the square root of 3 squared plus 4 squared, I really don't need a calculator to do it, but for some of the bigger numbers it would be a little convenient. 3 squared I know is 9, plus 4 squared I know is 16, and 9 plus 16 is 25, but when I square root that, it gives me the answer pretty rapidly, and that's just going to give me 5. So the absolute value of this complex number is 5. And I did it graphically and using the Pythagorean Theorem. I don't want to graph 7 minus 24i. I need a very large piece of paper. So I'm just going to jump right into the Pythagorean Theorem. And that's going to be the square root of something squared plus something squared, or distance formula if you want to look at it from a coordinate or analytic point of view. So I just drop the 7 in. Now a lot of people get afraid with the negative 24. What's negative 24 times negative 24? It's going to be positive anyway. So I just drop those numbers right in. I don't even worry about the sign value. And again, I'm going to use the calculator for this one. 7 squared I know is 49. Plus 24 squared, now I'm only guessing, I believe that's 576. And now I would have to add them and take the square root of it, but that's going to give me 25. So with the calculator, it makes quick work of these absolute value problems. So the absolute value of 7 minus 24i, the absolute value of that complex number, is just 25. The absolute value of negative 9 minus 40i, again, I'm just going to use Pythagorean Theorem. Some number squared plus another number squared. And in this case, the numbers are going to be 9. Don't even worry about the symbol. You don't have to. It would be eliminated in the squaring process. And 40. And now I would have to find that value, and I'm going to use a calculator again. Big numbers. 9 squared plus 40 squared. So that would be 81 plus 1600. 1681. Not too many of us know what the square root of 1681 is off the top of our head, but that's actually 41. And I used some Pythagorean triples that you might have noticed. So I got really nice whole number answers. For multiple choice tests, it might be a decimal. For a handwritten test, they might want it in an exact radical form. But that's how you find the absolute value of a complex number.